Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be talking about right triangles, again, trigonometry, and functions of trigonometry. Remember in the last chapter we talked about log and exponential equations, and we talked about the idea that those were what's called transcendental. Transcendental functions are different than algebraic functions. This is another example of transcendental functions. Trigonometric functions. What does that mean? Well, hopefully by the end of this lesson, you will be able to explain to me what it means. All right, let's jump into it, get started. We are on page 389. 389. All right, if you look down there, it lists the three different trigonometric functions. So let's talk about them. They're here on the screen. The first one is the sine function, S-I-N-E, sine. Maybe on your calculator you have noticed where it says S-I-N, sin. Now, I just want to let you know, you're not doing anything wrong. There's nothing sinful about pushing the sin button on your calculator. Some of you have been nervous about that for a while, but there's nothing wrong with pushing the sin button because it doesn't stand for sin, it stands for sine. That's this right here, S-I-N. Well, what does it mean? Well, we'll get to that in just a second. The second function is cosine, C-O, and then S-I-N-E, cosine. And that is, you're going to learn this later, maybe in pre-calculus, but maybe in this book as well. I don't remember if it goes through it, but it's what's called the cofunction of sine. That makes sense, right? Cosine, the cofunction of sine. And then the third one that we'll be talking about is tangent. Tangent. All right, so what do those mean? Well, here's what they mean. In a right triangle, there are different sides, and we've talked about that. Let me draw a quick right triangle here, and we know that this is the right angle, and so across from that, that is called the hypotenuse. Okay? Now, we also talked in last lesson about this. We called this the reference angle. Okay, the reference angle. So I'll leave that up there, reference. All right, now, if you look, if this is the reference angle that we're talking about, look at this. This would be the opposite side. Opposite. I'll put two P's, O-P-P. And this side would be the adjacent, A-D-J. So that's how we'll abbreviate those. Hypotenuse, opposite, adjacent. How do you get to the opposite? Well, you go to the reference angle and then you go across from it. That's the opposite. How do you get to the adjacent? Go to the reference angle and it's the one that touches the adjacent. We'll practice that a little bit more as we go throughout the lesson, but that's the important part that you need to know before we talk about what sine, cosine, and tangent are. All right, so what is a sine? The sine is the opposite over the hypotenuse. Opposite over hypotenuse. These are all what's called ratios. What's a ratio? A ratio is a comparison of two things. So we're comparing the opposite to the hypotenuse, and we're using division to do that. All right, the cosine. What is the cosine? The cosine is the adjacent over the hypotenuse. The adjacent over the hypotenuse. And then the tangent is the opposite over the adjacent. Opposite over adjacent. If you look in your book, that chart is on page 390. Page 390. Table C, it's called. Very important when you see table next to something in your book. That table is going to be very, very important for you. So it's all right there. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And the tangent is the opposite over the adjacent. Now, you say, I wish there was an easy way to remember that, because you're going to need to remember that. You don't need to be trying to find it in your book every time, because you're going to get lost really quick trying to do these. Maybe for a test or for a quiz, you're going to need to memorize them. So this right here, Sohcahtoa. This is a shortcut to remembering these. Sohcahtoa. If you can remember that, it's just like a weird word. It's not really a word, but if you can remember Sohcahtoa, I think of, if I ever hurt my toe, and I put it in water or something to make it feel better, I soak my toa. Okay, Sohcahtoa. And I don't know, that's dumb, right? Okay, but anyways, I I think of that like I can soak my toa. And so might be able to remember this. If you can remember this, great. You don't need it. I'm just kind of throwing it out there for you. You say, Mr. Steve, what in the world is Sohcahtoa? Well, let's go back to this. So, sine, opposite, hypotenuse. So, whoops, sorry. There we go. So, sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. And then toa, T, tangent, opposite, adjacent. Sohcahtoa. It's something, it's better than nothing, so hopefully that can help you to remember this. All right, let's do some of these, and let's talk about a couple different things first, and then we'll jump into it. So what's one more thing? There's one more little thing that we need to know. Here it is. This thing right here, it's like a zero with a line through it. What is that? This is the Greek letter theta. Now, I think I've told you this before, but I took Greek in college. And listen, it was a disaster. I am not made to speak or learn Greek. That's not my gift in life. But I remember a lot of these things. I remember the alphabet and different things. I remember the name of all the letters. And so this was something I learned about. But in math, and especially different branches of math like geometry, trigonometry, calculus, we use different Greek letters to say things. One that you all know and that we've been using a long time is the letter pi. That's a Greek letter, and you know that means the circumference of the circle, or 3.114. You should remember that. All right, now, what is theta? All theta means, here's what theta is. Theta is your reference angle. Okay, it's like the missing reference angle. We don't know what theta is. We don't know what the degree is necessarily of that angle. We just know we're talking about theta. Back in baby math, when we did these, we used this little thing on the angle. It's like a little curve thing right there to signify the reference angle. You're not going to see them use that anymore. That's going away, and now you're going to see a theta there. That means that is the reference angle we're discussing. So let's talk about this. Look at this triangle, and we're going to solve for the theta angle. The theta angle is our reference angle. So what is the sine of this one? Well, you have to remember, what is sine? So, S-O-H. So with S-O-H, what is it? Sine, opposite, hypotenuse. So let's identify the hypotenuse. Okay, here's the right angle. The hypotenuse is always across from the right angle, so you might want to write hypotenuse next to this guy. Which one is the adjacent? Well, this is our reference angle, and so the adjacent is the one that touches it. So this one would be the adjacent, and then this is opposite of our reference angle, because again, theta is our reference angle. So this one is going to be the opposite. Okay, now what we want to do is fill in the blanks with so. All right, so what does that look like? S is sine, O, opposite. Where's the opposite? That's 5. So 5 over what's H? That's the hypotenuse, 13. So your sine is 5 over 13. Now you would try to reduce that if you can. You can't in this case, so we're going to leave it like that. Cosine. The cosine is Sohcahtoa. There we go. Sohcahtoa. Now, what does that mean? Cosine, adjacent, hypotenuse. Okay, so where's the adjacent? There's 12, and the hypotenuse is still 13. It didn't change, stays the same. And then we do the last one, tangent. So toa, T-O-A, Sohcahtoa. Tangent means opposite over adjacent. So what's the opposite? 5. And what's the adjacent? 12. 5 over 12. So there's your three functions of this right triangle. Sine, 5 over 13. Cosine, 12 over 13. Tangent, 5 over 12. All right, next let's talk about Pythagorean's theorem. That is on the bottom of page 390. 390, Pythagorean theorem. What is Pythagorean's theorem? Well, here's what it is. Pythagorean's theorem is, it's a way to find the missing side of a triangle. So let's take a look at this. And I know we've done this before. We've done this in Algebra 1. We've done this in geometry. We've done this in 8th grade math. We've done this before. So this is not foreign to you. Shouldn't be foreign to you. So what does this look like? What are we doing here? Well, it's a squared plus b squared equals c squared. What is A, B, and C? Well, those are sides of the triangle. Notice it's small letter A, small letter B, small letter C. The sides of the triangle are labeled with A, B, and C in small letters. So let's take those and let's just plug them in and see what the hypotenuse is. Let's see what it gives us. A squared, 5 squared, plus B squared, 9 squared, equals C squared. Okay? All right, now let's go ahead and solve that. What is 5 squared? 25. Plus, what is 9 squared? 81. Equals C squared. Now we want to go ahead and we want to add those together. So you add 25 and 81. What do you get? 106 equals C squared. And you would solve that by square rooting both sides to get C equals the square root of 106. Now, you would try to solve that. You would try to reduce that if possible. I will tell you that you cannot reduce that one, but we would try. How do we reduce those? Well, we've already done a lesson on that. You need to go back and watch that lesson if you forgot. Reducing radicals. But you would try to square factor that. You would say, okay, does 4 go into it? No. Does 9 go into it? No. And you would try to square factor that thing. This next example is there on the next page. No, it's on the same page, 391. So on 391. Now we're going to kind of mix these two things together. So here we go. We have another triangle here, and notice that we're missing a side. So we need to figure out what that is. Well, check this out. This is the right angle, so this is the hypotenuse. We're missing the hypotenuse. Here's our reference angle, so which one's adjacent? This one's adjacent. This one's opposite. All right, so there we go. Well, we can do some of these, or at least one of these, without the hypotenuse. We can do tangent. Why can we do tangent? Because that's TOA. We don't need the hypotenuse. We just have the opposite over the adjacent. So that would be 3 over 6. Remember, I told you to reduce those if you can. How do we reduce 3 over 6? Well, we reduce it to 1/2. So the tangent for this one would be 1/2. All right, now how are we going to get the sine and the cosine? We're missing this one. We're just going to put it over x? No, we're going to figure out what x is. How do we figure out what x is? With a squared plus b squared equals c squared. Okay, so this is c. The x is the c, or the hypotenuse. So we're going to have 3 squared plus 6 squared equals c squared. So let's go ahead and keep solving that out. We're going to get 9 plus 36 equals c squared. 9 plus 36 is 45 equals c squared. Can you reduce out 45? Well, you can, because what goes into that is, and this is square root, because we have to square root both sides. So we reduce that out, and we get 9 and 5. What comes out of that? The 3 comes out, so we have 3 square root of 5. That is the hypotenuse. 3 square root of 5 is the hypotenuse. So now go over to your sine, and we're going to have opposite over hypotenuse. And so the opposite is 3 over 3 square root of 5. Cosine is going to be 6 over 3 square root of 5. All right, now this is interesting right here. There's a couple things that we can do. The first thing that we can do is we can cancel these 3's. So we're going to get 1 over the square root of 5. Now, you might think, well, that's my answer. I need to go ahead and circle that. Well, it's not. Do you remember about rationalizing denominators? We always have to rationalize the denominator. What does that mean? So if we have 1 over the square root of 5, again, if you're struggling with this radical stuff, you need to go back and watch the videos from that radical chapter. I can't remember what chapter it was, maybe chapter 3, 2, something like that. I don't remember where it was. But go back and find it and watch these videos. We have to convert this. How do we do it? By multiplying both by the square root of 5. And what that's going to give us is on top square root of 5 and on the bottom square root of 25. That solves out to 5. So we have square root of 5 over 5. That's our answer. We have to rationalize the denominator. I did that quickly because you should know how to do it. So that's going to equal 5 over, let's do that. Square root of 5 over 5. There we go. So that's the numerator. Denominator, we need to do the same, or the cosine, we need to do the same thing. So we're going to cancel that to a 1, cancel that to a 2. So we're going to get 2 over square root of 5. Okay, well, again, we need to move that out of the denominator. So let's do that one. 2 over square root of 5. We're going to multiply both of them by the square root of 5. And we're going to get 2 square roots of 5 over square root of 25, or over 5. So 2 over 5, square root of 5. 2 over 5 square root of 5. I wrote that a little differently, okay? And so you can write it either way. So this one on top, I did it as a fraction. This one, I did it more like as a mixed number or a mixed fraction, okay? And so you can write it either way. It doesn't matter which way that you write those. All right, let's do one more. We're going to do this one fairly quickly, so kind of hang on to your hats here. What are we doing here? What's going on here? Well, none of this is labeled this time. What's happening? Well, they gave us the sign. So what did they give us? What does sine? Opposite over hypotenuse, right? And so we're going to put the opposite. Here's the reference angle. So the opposite is square root of 2. So this is square root of 2 over here. This is the hypotenuse because it's opposite of the right angle. And so the hypotenuse is 3. Now we're looking for the b side. How do we find the b side? Well, a squared plus b squared equals c squared. Now just plug them in. So square root of 2 squared plus b squared equals 3 squared. Well, this one's interesting because that just cancels and we get 2. Plus b squared equals 9. We're going to subtract 2 from both sides, and we're going to get b squared equals 7. And so square root each of those, and we're going to get b equals the square root of 7. So that side is going to be the square root of 7. And now we can fill in the rest of them because now we have the opposite side. So this would be, the cosine would be the adjacent over the hypotenuse. And so what's the adjacent? The adjacent is the square root of 7 over 3. And what's the tangent? So the tangent is opposite over adjacent. And so the tangent would give us the opposite is square root of 2. The adjacent is square root of 7. We can't leave that like that, don't forget, because that's got a radical in the denominator. So we would solve that. Square root of 2 over square root of 7. We'd multiply both of those by the square root of 7. And we would get the square root of 14 over square root of 49 or over 7. So square root, this would be square root of 14 over 7 would be our answer, and that would be the tangent. Okay? Ooh, lots of stuff going on there. That was an exciting lesson. Sorry, it took just a little bit longer than I would have liked, but I wanted to get that all in one lesson for you there. Okay, if you have any questions, slide it back. Make sure you try some of those. Go practice. There's lots of exercises there in the following page, so try some of those, see how you do. If you missed anything, go check it out, rewind it. All right, we'll see you later. Have a good one. Bye-bye.